ETL versus ELT, extract, transform, load, or extract, load, transform. Marcus, a senior data platform engineer, opens the design doc for a new pipeline. He types the question every data team asks once: should we transform before loading or after loading? For decades, the answer was obvious. Then, around 2015, it stopped being obvious, and most engineers still cannot articulate why. That is what we are going to fix in the next 9 minutes. To understand the shift, start with the constraint that made ETL the only option. In the 1990s, disk was expensive, hundreds of dollars per gigabyte. Warehouses were measured in low terabytes. You could not afford to land raw source data. You had to transform it first, filter it aggressively, aggregate it aggressively, then load only the shape you needed, extract, then transform in staging, then load into the warehouse. Transform first was not a preference. It was survival. Then the constraint collapsed. Between the 1990s and today, storage cost per gigabyte fell by 4 to 5 orders of magnitude, from hundreds of dollars per gigabyte on-prem to fractions of a cent per gigabyte in cloud object storage. When storage got cheap enough that keeping raw source data became almost free, the physical reason to transform before loading went away. A different order became viable: extract, then load raw, then transform in place. ELT. Modern ELT looks like this. Managed connectors pull raw data from sources into your cloud warehouse or lake. It lands as raw tables, no transforms. From there, SQL frameworks built clean tables downstream, orchestrated as directed acyclic graphs. The transformation logic lives in the warehouse, runs on warehouse compute, and can be rerun against the same raw source data, which unlocks something that ETL never had. You can rebuild any transform. You cannot rebuild lost source data. 3 things ELT gives you almost for free. 1. Idempotent transforms. Rerun the same SQL, get the same output. Bug in your logic? Fix and rerun. No re-ingest needed. 2. Source data preserved. When a new question shows up next month, you query directly from raw. Any lost detail is lost forever, so raw is your insurance policy. 3. Faster iteration. Analysts build their own transforms in SQL without touching the ingest pipeline. The bottleneck stops being the data engineering team. Nothing is free. The build just shifted. 1. Warehouse compute cost. Every transform now runs on the warehouse, and the analytics team sees a monthly compute bill they never used to see. 2. Schema drift and governance debt. Keep everything can become nobody knows anything. If you have watched the Schema on Read episode, this is the swamp we talked about. 3. Governance now lives downstream. PISA retention and audit checks all live in transforms. If you skip them, compliance review will find you. ELT is not the universal answer. 3 cases where ETL still wins. 1. Regulated data. If it is PII, FI, or PCI, you legally cannot land raw source data in your warehouse. You have to redact, tokenize, or mask before it lands. That is T then L. 2. Cost-constrained warehouses. When warehouse compute is your bottleneck, transforming earlier is cheaper. ETL trades storage cost for compute cost, and that trade is still real. 3. Legacy source systems. Sometimes the source only exposes transform views. You get what you get. Most mature data platforms ship both. Layered. Bronze holds the raw as ingested data. Cheap to write, expensive to query, preserves everything. Silver holds cleaned, typed, deduplicated tables. 1 transform pass on top of bronze. Governance and data quality live here. Gold holds business-shaped tables. 1 more transform pass, denormalized for dashboards and reports. Every mature platform ships all 3. ETL versus ELT stops being a binary choice. Both patterns live in the same stack. The principle that outlives the vendors. Storage cost curves shape architecture. Every best practice has an era. Every architecture is a response to a constraint, and constraints change. When cost curves shift, the architecture that was best practice quietly expires. The engineer who watches constraints, not just tools, sees the next shift 5 years before their team does. That skill is worth more than any specific vendor recommendation. This is episode 1 of the architecture track on this channel. 5 more deep dives are coming. Warehouse versus lakehouse. Star schema versus snowflake versus one big table. Medallion architecture in production. The modern data stack, layer by layer. And data mesh, where Conway's law hits your data platform. Each answers the same question at a different scale. What constraint is your architecture actually responding to? Subscribe and hit the bell to catch the next deep dive in your feed.